All right, so number 54. So number 54 is originally here. Let's see. So it's three fractions, three rational expressions that you're adding. So the first thing you have to do is find the common denominator for each of them. What's their common denominator between the three? So I actually worked this problem out. So the first thing when you're finding a common denominator, you have to break down as far as you can. So to determine whether, so these two are monomials. So x just stays x. 2x squared is a monomial. So it's just 2 times x times x. X plus 2 is a binomial. So with a binomial, the way to factor a binomial is GCF, greatest common factor. Well, the GCF for this guy is just 1. So that stays the same. And then what you do is you figure out what do they all need. What do they all three of these guys, this guy, and this guy, to be the same? Well, this guy is going to need an x plus 2, and it's going to need a 2 and another x to match. This guy over here already has two x's, so it doesn't need an x, and it doesn't need a 2, but it's missing an x plus 2. And then this guy over here has the x plus 2, but it's missing everything else. So all of these now are identical. 2x squared, and then x plus 2. And then so whatever you needed to include here, you also include to the top. So this becomes 2x times x plus 2, so I just distribute it. This becomes 3 times x plus 2, so I distribute it. And then this becomes 8x squared. So when you distribute, this is what you get. And then you combine like terms, and you are done. 59. 59 is similar, but it's multiplication. So you're multiplying two fractions, two rational expressions. So to do that, the first thing you have to do is factor all numerators and denominators. Okay, so this one in pink is a monomial. So you just break it down. 3 times x times x. The yellow is a binomial. So GCF would be 5. So when you divide them both by 5, you get x plus 3. The orange one is a trinomial. So trinomial depends on how you taught. Most teachers teach the diamond method, where you multiply the first term times the last term, and then you find there, and then you figure out the two numbers that multiply to be 3 and add to be 4, which will be 3 and 1. 3 and 1. And then the blue at the end is a binomial. The thing about it, though, is its GCF is 6. This here is difference of squares. So you can see here it breaks down again. Okay, so now multiplication, you just multiply straight across. So all I did was write everything on top over here, and then everything on bottom over here. Plus I did difference of squares there. And then after that, you just multiply, you just cross out. Everything's multiplication, so cross those out, and then 3 and 6 are monomials, so 3 goes into 6 twice, once there. So you're just left with x squared on top, and then 5x minus 1 on bottom. Oh, sorry, 5 times 2. 5 times 2. Okay. 64. So 64, or sorry, yes, 64. The question was just write each without negative exponents. That's it. That's all you have to do. So this guy is the only one with a negative exponent, x to the negative 5. The 2 does not have a negative exponent. The only thing that has a negative exponent is x. So how do we change that? We just move it. If it's on bottom, we move it to the top. And then you simplify, and you're done. No more negative exponents. Number 72. said write it without a fractional exponent. Well, fraction exponents, the top is the power, the bottom is the root. So really, this question is just saying the third root of x squared. That's all it's saying. Then you're done. No more fraction powers. Okay. Number 93, the question is, I want to know the domain. Anytime you're doing a domain, you look at the bottom. That's going to tell you the domain. You set the bottom equal to 0. Where, whatever values you get, that's where the domain can exist, right? Wherever the domain, wherever the denominator is 0. So when I set it equal to 0, I subtract 2 from both sides, and then I take the square root. Well, the square root of -2 is an imaginary number. So that means no real numbers. There are no real restrictions. There are no domain restrictions. So that means the domain exists everywhere. Okay. If this was x minus 2, you'd add 2 to both sides. You'd do the same thing. The only difference is you'd get an answer. You'd find the square root. So it'd be plus or minus the square root of 2, right? That exists. So you'd have a domain restriction there. But here we don't have any restrictions since the only restriction is imaginary. Okay? And in calculus, we don't deal with imaginary. We only deal with the real. Okay, and then the last one, 107. So you're solving a natural log equation. So the first thing you're going to do is, so remember, natural logs, anytime you see natural logs, all it means is log with a base of e. That's all it is. Okay, so to do that, we want to solve for x. X is what we want to solve for. So to do that, we need to get rid of the log, because the log is not going to help us. So to do that, you need to change it to an exponent. So the little trick I use is I use a little cursive e. So e to the -2 power equals 2x minus 3. So now it's not in log form, it's in exponent form. So the last thing to do is solve for x now. So you add 3 to both sides, since they're not like term. You leave it like that, and then you divide by 2. Divide everything by 2. So you're going to have e to the -2 divided by 2 plus 3 over 2 equals x. The only other thing, that's the correct answer, but the only other thing is maybe this guy has a negative exponent, so you might have to move that down. So it would be 1 over 2e squared plus 3 over 2 equals x. Either one would be a correct answer. If it's a free response question, I'd take both answers, because the question didn't say all exponents had to be positive. But if it's a multiple choice question, either one or the other would be there. Okay. If you have any other questions, just let me know. Hopefully this video helped.